Hello Legacy Savers and welcome to Graphing Square Ruts. What you're going to want to have on you today, the graphing notebook or those papers I gave you in class, a pen or a pencil, and then you're going to want maybe two different colors of pens or a pen and a pencil or something along those lines, alright? So let's review the general shapes of what we've already learned this year. So y equals x squared, remember that was our parabola shape, it looks something like that. Absolute value looks something like this, had a V shape to it, kind of like that, points on both sides. Y equals mx plus b, that was a line, straight line, right? Y equals x cubed, that was a line going like this, not a line, more like a sideways S, remember? And then y equals x to the fourth, that did either a loop-de-loop, kind of like a W, or it did just a normal parabola, depending on what our other terms were. So let's look at a new function graphed. So we're going to look at the parent square root function. So the parent square root function looks something like this. So notice it's just like a curved line that kind of shoots off to the right. There's a couple of points I want you to mark down or kind of look at. So one dot right here is at 0, 0. I wanted you to really pay attention to 0, 0. And then another dot that I would pay attention to would be 1, 1. Those are two dots that we're going to always want to graph on our square root parent function. And then what we're going to be able to do is move those dots based on our transformations, which we'll cover on our next slide. Domain, remember, domain's all your x values, so the furthest x on the left-hand side, so the least amount of x is 0, right? Because I don't cross over here, but I do hit at 0. So I'm going to start at 0 and go off to positive infinity, right? Because I'm going to get all the positive x's. So to positive infinity. Range, notice, not getting at the negative y's, I'm only starting at 0 as well. So I'm going to start at 0 for my y's. But this guy's going to keep opening up, 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 and up. So I am ultimately going to reach a positive infinity with my range. If I would look far off into the right hand side, I would go my function's going to keep opening up. Now let's kind of go back a little bit to graphs and how they shift. So g of x equals x squared, remember? And g of x equals x squared minus 8. Well, when we had something at the end of our function, like a plus 3 or a minus 8, this made you move up or down. In this case, we would have gone down 8, right? Because that's going down. Remember the negative on the outside, that basically flipped it or reflected it, depending on how you want to say it. Normally our u would go like this, but that made our u go like that. So it basically took the u and flipped it or reflected it across. What happened when we had something inside the squared? Well, that moved us left or right. And remember, guys, this was opposite of what you thought it should do. So it's a plus 6, so normally we would have said, well, that's right 6, but it's actually left 6. So remember, it goes backwards for what you thought it should do. Then we had a whole bunch of stuff in there. So we could go right 4, up 5, and this number out here, if you remember, changed how the graph, like if it made it a little skinnier or made a little fatter of a u, depending on what the number was. So what does this look like as a square root? Well, here's my parent function. If I add anything on the outside, just like when we subtracted the 8 up here, that's going to move you up or down. So if I add something on the outside, it's going to go up. If I subtract something on the outside, it's going to make my function go down. What if I have something underneath the square root with the x? So that'd be like x plus 3 underneath the square root, or x minus 5. That's going to move you left or right, just like this did. So this, if I have a plus underneath, it's going to move you left. Negative is going to move you right. If I have a number on the outside, that is going to make me either stretch or compress my function, so that's going to make it go gain height faster, or it's going to make it a lot smaller than it normally would be. And if you have a negative, that's going to reflect the front of the function. So it's going to reflect it and make it not go shooting up, but shooting down. So let's take a look at a couple of examples of square root graphs while shifting them. So I have the square root of x minus 3 plus 4. So what I'm going to do on each graph is I'm going to graph my two dots on my parent function. So I'm going to graph 0, 0, and 1, 1. Then I'm going to take my graph and kind of make it so it's not a straight line, remember, because it kind of curves. So we're going to do our best to curve my line like that. Now, I'm now going to use my second color here and figure out how did I shift. Well, x minus 3 underneath the radical sign. That's going to move you right 3. This is going to move me up 4, right? So this dot, let's do that. Let's actually do these with my two dots. So I'm going to go right 3, 1, 2, 3, up 4, 1, 2, 3, 4. Put a dot there. Same thing with this dot, 1, 2, 3. 1, 2, 3, 4. And then I get to connect my dots and kind of do the nice shoot off corner like that. So now I'm going to do my domain and range of my translated function, my purple guy here. So it looks like the furthest x value I hit is 3, right? Don't cover anybody behind him. So I'm going to start at 3 and go off to infinity. Range, notice the lowest y is 4, but I do go off to infinity because I'm going to keep growing up and up and up. Okay, let's take a look when we have a negative on the outside. What is it going to do? So the very first thing, I'm going to graph my parent, 0, 0, 1, 1, shoot them off. There we go. Okay. Now, let's take a different color here. Let's go green. So I'm going to move right. Oop, no, bad marsh. Left 2. Almost fall into a victim. Down 1. And then this is going to flip it, right? The negative. So let's follow my directions with my graph here. So I'm going to go left 2, 1, 2, down 1. So now, normally we would have gone and moved this, right? So then we're going to move this left 2, down 1. But notice that's going to be a graph that looks like that. We don't want it to be a graph that looks like that. We want it to be a graph that kind of mirrors this. So notice how this is up 1 over 1. I can do the same thing. I can go down 1 to the right 1 to make my new graph. Because that would be a negative, you can almost think of this as a -1 slope, if you want to think of it that way. That will help you see your graph so that it creates a nice graph that is flipped but yet shifted. Now, let's look at our domain and our range. So the furthest domain value I cover is -2. So I'm going to start at -2 and go off to infinity. Then my range, notice I start at -1, but that's the highest y value that I'm going to cover because I'm going to get all the negatives. So I'm going to start at -infinity and get to -1 because this is going to cover all the negative y's and then it's going to stop at -1. So it's kind of backwards from the other positive when you don't have the negative out front. Let's take a look at our last example here. So I have 2 times the square root of x minus 1 plus 6. So I'm going to first graph my parent like that. Now let's think of how this guy's moving. Let's go blue. So this is right 1, up 6, and then this is kind of like a slope to find my second point here. So let's graph my new start point. So I'm going to go right 1, up 6. 1, 2, 3, 4, 5, 6. Now, normally we would have gone up 2 over 1, or up 1 over 1, right? Well, this is my new slope. To find that next dot, you're going to actually go up 2 over 1. So I'm going to go up 2 over 1. Now I'm going to connect my dots, try to make it still curved. Notice, guys, this gained a little bit more height because the 2 is on the out front. It made it a lot more height, and it's going to gain height faster than a normal square root function. Let's spot our domain. So I start at 1, go off to infinity. My range, it looks like I start at 6 and I go positive. So I'm going to start at 6 and go to the positives. And that's the end of this video. See you later, Sabers.